Hi, Assalamualaikum. So today we'll be presenting about capacitance. So before we begin, I would like to introduce my fellow teammates. First of all, we have Nuraryani binti Mohamad Nor, Nurizzati Damia binti Amir Hamzah, and Nur Eva Natasya binti Mohamad Shahril, Ainur Najieha binti Zulkefli, and lastly, Ainur Najieha binti Radzi.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraryani binti Mohamad Nor, and we will move on into experiment 2, which called capacitance. Before we move on into procedure, I will talk about objective for the experiment. First objective of the experiment is to study the capacitance variance with the separation between the plates. 2. To study the capacitance variance with the area of the plates. And lastly, to study the dielectric effects on the stored charge, energy and voltage between the plates of the capacitor when it is connected or disconnected from the battery. There is two parts for procedure. One is capacitance and 2 is effect of dielectric on the capacitor. I will start for the part 1 for the experiment. First procedure is paper was chosen as the material of dielectrics. The capacitance was checked. So the capacitance meter can be seen before the dielectric completely insert inside the capacitor, like these pictures below. Next, the values of plate area should be smallest as possible. Distance between the plates should be larger as possible, and corresponding capacitors are recorded. Third procedure is the plates area is slowly increased and the corresponding capacitance are measured for more times. Results are recorded in the table. Excel is used to plot the capacitance as dependent variable against the area. Then a trend line is added to approximate the data with the linear model. Next, the area is restored to initial. The separation between the plates decreases slowly and the corresponding capacitance measured for more times. The results were recorded in table along with the reciprocal of the separation. Just like before, Excel was used to plot capacitance as the dependent variable against the reciprocal of the separation between the plates. Then linear regression used to draw the phase fit line to approximate the data with the linear model. Now we move on into part 2 for the procedure for experiment 2. The values of plates area and the plate separation was retrieved to the original and remove the dielectric entirely from the capacitor. The capacitance, charge, voltage and energy meters were shown by checking off the approximate boxes on the right of the simulation. We will have to connect the voltmeter. The red electrode was placed on the plate with the positive charge and the black electrode on the plate with the negative charge, like this picture below. Then the battery was connected and turned on the voltage into 1 volt. Next, the dielectric was slowly inserted inside the capacitor as the electric filled more space in the capacitor. The changes observed and recorded in capacitance, charge, voltage between the plate, energy stored by the capacitor. For the fourth step, we just had to repeat the step 3 and record the same changes, but we will disconnect the battery and remove the dielectric entirely. I think that's all from me. Now we move on into presentation of data and analysis of graph that will be presented by Eva.
For the data for part 1 capacitance, we can see for plates area A, for 0 is 1 times 10 power of negative 4, for 1, 2 times 10 power of negative 4, 2, 2.5 times 10 power of negative 4, 3, 3 times 10 power of negative 4, 4, 4 times 10 power of negative 4, and for capacitance C for 0 is 0.31 times 10 power of negative 12, for 1, 0.62 times 10 power of negative 12, for 2 we got 0.77 times 10 power of negative 12, for 3 we got 0.93 times 10 power of negative 12, and for 4 we got 1.24 times 10 power of negative 12. And that's for table 1. For table 2, we got distance between places D. So for 0 is 0.01, for 1 we got 0.009, for 2 we got 0.008, for 3 we got 0.007, and for 4 we got 0.006. The reciprocal of the separation between the plates, 1 over D. For 0 we got 100.00, for 1 we got 111.11, for 2 we got 135.00, for 3 we got 142.56, and for 4 we got 166.67. And for capacitance C, for 0 we got 0.31 times 10 power of negative 12, for 1 we got 0.35 times 10 power of negative 12, for 2 we got 0.38 times 10 power of negative 12, for 3 we got 0.44 times 10 power of negative 12, and lastly for 4 we got 0.51 times 10 power of negative 12. Next for part 2, we got effect of dielectric on capacitor. For the connected batteries offset M, we got 0.01, 0.008, 0.006, 0.004, 0.002, and 0, respectively. For capacitance, we got 0.89 times 10 power of negative 13, 1.33 times 10 power of negative 13, 1.77 times 10 power of negative 13, 2.21 times 10 power of negative 13, 2.66 times 10 power of negative 13, and 3.10 times 10 power of negative 13. For charge C, we got 0.91 times 10 to the power negative 13, 1.37 times 10 power negative 13, 1.87 times 10 power negative 13, 2.28 times 10 power negative 13, 2.74 times 10 power negative 13, and 3.19 times 10 power negative 13. The voltage between the plates, all of it, we got 1.031. The energy stored by the capacitor J, we got 0.47 times 10 power negative 13, 0.71 times 10 power negative 13, 0.94 times 10 power negative 13, 1.18 times 10 power of negative 13, 1.41 times 10 power negative 13, and 1.65 times 10 power of negative 13, respectively. For the offset and capacitance of disconnected battery, it is the same as the connected battery. The charge for the disconnected battery is all the same, which is 0.91 times 10 power negative 13. But for the disconnected battery's voltage between the plates, we got 1.031, 0.687, 0.515, 0.412, 0.344, and 0.294 respectively. The energy stored by the capacitor, we got 0.47 times 10 power of negative 13, 0.31 times 10 power of negative 13, 0.24 times 10 power of negative 13, 0.19 times 10 power of negative 13, 0.16 times 10 power of negative 13, and 0.13 times 10 power of negative 13 respectively. Next, we will move on for the analysis for part 1 capacitance. From the graph it plotted, we can see that from the capacitance versus area graph, capacitance is directly proportional to area, which means as the area increases, the capacitance also increases. For the analysis part 2 of effect of dielectric on the capacitor, we can see that from the graph capacitance versus reciprocal of the separation between the plates 1 over P, after we plotted it, we can see that capacitance is also directly proportional to the reciprocal of the separation between the plates, which means as the reciprocal of the separation between the plates increases, the capacitance also increases.
So next, we're gonna look at the equation. So the first question is if the battery is connected. Is the energy of capacitor battery system conserved throughout the process of inserting the dielectric? Explain the changes energy, if any. So the answer is the energy of capacitor battery system is not conserved as it increase throughout the process of inserting the dielectric. This is because of the capacitance of a parallel plate circuit was proportional to the plate area. So thus, the larger the plate area, the more charges can be stored. The capacitance will be increased. So next question, if the battery is disconnected, does the energy stored in the capacitor remain constant as the dielectric is inserted? Explain the changes of energy, if any. So for this question, the answer is the energy stored in the capacitor increase as the dielectric inserted. This is because the capacitance of a parallel plate capacitor was inversely proportional to the separation of the plates. As the distance between the plate further away, the less charge can be stored. So the capacitance will decrease. So I will pass to the next person, which is Fatin, to continue this presentation.
Thank you, Najieha. Assalamualaikum. My name is Ainur Diana, binti Zulkefli. So I will continue with discussion part. So from this experiment, we knew the relationship between the area of plate and capacitance of parallel plate capacitor, which is if the area of plate increase, the capacitance of parallel plate capacitor will increase too. This is because a larger area able to store more charge. Next, we knew when the electric was insert inside the capacitor, polarization of atoms and molecules will occur and it is going to stretch and orient themselves. So the capacitance of capacitor will increase based on the equation C equal to KQ per delta V. Next, when battery was connected, energy stored is increasing because more work was done in order to change lower to higher potential, while when there is no supply, the amount of energy stored was decreasing as less work required to transport the charge. So I will pass to Damia to continue this presentation.
Thank you, Fatin. Assalamualaikum. My name is Nurfatin Diana, binti Amir Hamzah, with the student number 2020-68468. Now, I'm going to conclude for experimental capacitance. The objective of the experiment is to study the capacitance varies with the separation between the plates by following the procedure given. The formula of parallel plate capacitance was used to explain the experiment. Capacitancy is inversely proportional to the distance d. Thus, when the distance decreases, capacitance increases. Next, this experiment was conducted to study the capacitance varies with the area of the plate. We can explain this by using the same formula. From the formula, capacitancy is directly proportional to the area A. Hence, when area increases, capacitance will also increase. Moreover, this experiment was also carried out to study the dielectric effects on the stored charge, energy and voltage between the plates of the capacitor when it is connected or disconnected from the battery. The percentage error between the theoretical value and experimental value is 0% because the experiment was done using flat simulation. That's all from us. Thank you.